to make sure.
No.
Alright,
Should've said
so-
no.
Obsessively fat for no reason.
No, it's not. That is not happening. Alright, we'll start with Ethan. So Ethan, close up your book. We're gonna do the cations
Oh, come
mainly.
on.
Alright, we're gonna do the cations mainly, but then I'll start introducing some of the anions because you gotta know these. Okay. But you gotta know them, because remember, when's the quiz for it?
Next week.
Wednesday.
week.
So make sure you're studying. Alright, Ethan.
Leavenworth.
Good job.
Peanut butter. Magnesium 2.
Is there more than one magnesium?
Magnesium.
Just magnesium.
Ooh.
Alright.
Sodium.
Is there more than one sodium?
Nope.
Nope.
Ooh.
Iron 3.
Good job.
Iron.
Iron 3.
Iron.
Calcium.
Okay. Oh, is there more than one calcium?
No.
Yep.
What's that one?
Sin.
10.
There you go.
10
Good job.
Copper.
But it has it.
Copper 1.
There you go.
Hydrogen.
Is there more than one hydrogen? Nope.
No.
Trickier one.
That's easy.
Mercury.
Is there more than one type of mercury?
Come on. Mercury 2.
Mercury 2.
These are easy.
Iron 2.
Good job. It's one, once you get it, it's okay. We're gonna get trickier.
Copper 2.
Good job. This one's the weird one.
So is that,
Hope you can see that.
Mercury,
I'll zoom in.
Mercury 2? Mercury.
Alright, so there's 2 mercuries, and each one
So Mercury 4.
has given up 1 because the total charge is positive
Mercury
2.
2.
But each mercury's only given up
Mercury
1.
1.
Mercury 1, because there's 2 of them. Each one's given up 1 to give a total 2 charge. I know
2
this
divided
one's,
by 2 is 1.
yeah, I know this one's a little weirder, a little harder. I'll put it up beside. It's one of those, once you get it, you got it. Alright, what's this one, Ethan?
10. 4.
Good job. Alright, we'll introduce some of the harder, some of the easier anions in a second. I'm gonna put that over to the side.
I'm actually gonna try
Yay!
on anions. Cations I'm not gonna try.
Okay, this is an anion, but you should be able to note this one. What is this one?
Fluorine.
Alright, change the name.
Fluoride.
Fluoride.
Negative
That's it.
fluoride.
Nope, just fluoride. But yeah, that's it. Alright, what is this anion?
Iodine.
Good job. What's this one?
Oxide.
Good job.
Ooh.
Sulfide.
Which one?
Sulfide.
Sulfide. Yeah, some of them are easy. Oh, here's another cation.
Calcium. No. Potassium.
Potassium.
Is there more than one potassium?
No.
That's it. Alright.
So,
Is there more than one silver?
no.
Alright.
Lead 2.
Good job. Oh, put this one on the side. It's a little
I'm
harder.
gonna guess that one.
Alright.
I know it if you don't know it.
I know. Aluminum 3.
Alright, what's the charge
Aluminum.
of aluminum?
To what?
What's the charge of aluminum?
3.
Is it always 3?
Yes.
Yes, it is. This is one you need to memorize. It's always 3.
Aluminum 3?
Yep. Well, just aluminum because remember the charge doesn't change. It's only one form of it. Alright.
Zinc.
Is there more than one form of zinc?
Zinc 2.
Is there?
Yes.
Or is there?
Yes.
No.
Just zinc. Just zinc. Okay.
Just a little bit.
Just lip zinc.
Oh, this is the weird cation you need to know.
Uh,
What's the name for this one?
is it?
Is
It starts with an A.
Just her name.
Ammonium.
Ammonium. Not ammonia.
That's my
Ammonia.
name.
Let's see. Where's another easier one? Then we'll introduce another hard. Oh, you should probably start to know what this one is.
I know what it is. I know what it is.
Oxygen hydroxide.
I can't say it.
Okay, it's just hydroxide.
Oh,
Yeah,
come on.
Hydroxide for this one. Oh, here's an easier one.
Corn.
Which one?
Corn.
Oh, change the ending.
Zinc.
Wait, what?
Because it's an anion, change the ending.
Chloride?
Chloride.
Oh,
Correct.
So it's one of those, once you start getting them, it's like,
This
oh,
is easy. It's not that bad.
I'm getting it.
Sulfate.
Sulfide, but yes.
Correct.
I have a second
What's she
oxygen.
do
I'm
all?
not sure why. Put that off to the side. Alright,
Bromine.
bromide.
Oh,
Okay, let's see.
Harder ones.
Bromine.
Alright, we're
Bros.
gonna introduce Signature.
Ammonium.
Ammonium. Alright, what is this one again? This is a harder cation.
Mercury one.
Mercury 1. Alright. Just, you want to use your book, you can.
Nitrate. Nitrite.
Nope.
Carbon dioxide.
No, you're not going to figure it out with that. Alright, Ethan, you want to guess?
What is it?
Alright, cyanide.
Carbon dioxide.
Write it down. Write it down. Get out a piece of paper. So we can make
Oh,
this-
cyanide?
Cyanide.
I'm gonna remember that one easily now.
Cyanide.
CNN?
Wait,
Cyanide?
just
I
see
know.
it. Cyanide.
CNN is like bad, so cyanide is
Okay,
bad.
that helps you? Whatever. But yeah,
That
but I
does
know for these you can't really figure out. You gotta just learn. Alright,
Sayonara.
cyanide. Yeah. Alright.
Cyanide.
I was you're gonna have to just find this one because there's no tricks for it. Technically,
Sulfate.
this is sulfate.
I was going to say that
Yeah.
actually. I was going to guess that.
Alright, so
Sulfite.
you might can guess this one, Ethan, because we've practiced with it a little bit.
Nitrate.
Nitrate or nitrite?
Nitrite.
Which one?
Nitrate.
Nitrate. Because
You're
there's
right.
3 O's. Okay, what's this one?
Coke. That's carbon dioxide.
Carbonate.
Carbonate. Good job. Alright, what's this one? Because there's 2 O's.
Oxide.
Okay, well,
Ni-
nitrate had
nitrate,
NO3.
Nitro.
That's good. Nitrate. Nitrite.
Nitrite.
Oh.
Good job. So, the A has 3 O's. The nitrite has 2 O's. So, there are tricks, they're just a little harder. Okay. Should be the one very bottom of that chart.
Phosphate.
I
Phosphate.
know that one.
Alright, what's this one?
Let's start with.
You gotta just look in the book, but there's not a whole lot of tricks for these.
I'm the answer.
What was that?
Sulfide. Sulfate.
Which one?
Sulfate.
Sulfate. You get 3 O's.
Good.
That's help you out. The 8s and ites.
It's silicate in here.
I'm sorry. Did you say
That's what I
sulfate
meant.
or
That's what I
silicate?
meant.
You said
I'm sorry.
sulfate.
That's what I meant.
Sulfate's right below it. There's nothing here.
Silicate. That's what I said.
No, you didn't. I was thinking SI, and I heard sol. I was listening for the ending, so I missed the first part. But it's silicate, so you are right.
right.
You both get a point for it.
Oh, wait,
Wait, we're doing points?
Oh, never mind. You don't get.
We both get candy.
All right, this one I think is at the very
Oh,
top.
I know that one. I know.
Never mind.
Acetate.
No.
Acetate. You're just gonna. This one's just hard.
What's that one?
No, you're just gonna. It's just hard.
Starts with an H?
No.
Starts with P.
No.
Starts with an
No, you just have to memorize this
I know.
one.
A. Ammonium hydrate.
Dihydrogen phosphate.
So yeah, dihydrogen phosphate.
Get
So you're just
wrecked.
gonna have to just-
Dihydrogen, there's 2.
Yep.
And then what?
Phosphate.
Phosphate. Okay, I
It's one of
remember
those. Once you get it, it's not hard, but it's just learning them. Don't scratch
that.
it.
Yeah, I haven't even looked at that yet.
Bisulfate.
Which one?
Bisulfate?
Bisulfate.
I'm not even looking, boy.
Yeah, you are.
Alright,
Chromite. Chromite.
change the ending.
Chromite. Chromite.
There's 4 O's, lots of O's.
Chromite 2.
No.
Chromate.
Wait!
Chromate. The 8 refers to having a lot of O's. That's a simplified definition, but that's the reason why those 8 endings keep popping up. Right?
Hydrogen phosphate. I wasn't even looking. Hydrogen phosphate.
Yeah, you
Hydrogen
are.
phosphate. So remember, the dihydrogen phosphate had 2 H's, so they kind of sort of make
I'm not
sense.
even on the page.
Hydrogen phosphate. Okay.
Alright, well this one's weird. There's-
Hydrogen.
It's weird.
I'm not even on the page. I'm not aware.
Starts with B. It's not helpful.
I know.
Okay.
Bicarbonate.
Yep.
Halo.
Bicarbonate.
On what page?
Chris, you know I can see you flipping it. Come on. Why? Okay, Ethan.
I got exposed.
Cora.
Okay, change the ending. Lots of O's.
Kool-Aid.
Kool-Aid. Kool-Aid.
Kool-Aid?
Kool-Aid. Kool-Aid.
Chlorate.
Oh.
Alright.
Kool-Aid.
Yeah, but they gotta find this
Let
one.
me think. Let me think. Dichromate.
Good job, dichromate. Alright, I only have 2 left, so that's the whole chart. This one's weird. Sorry. Sorry. This is a weird one.
It does not with that, does it?
It doesn't start with the N or
It
anything.
doesn't start with that.
Pomegranate.
No. Okay.
It's permanganate.
Okay. Permanganate. Excuse me. So permanganate. So make it up. So magnesium, and then it has the O in it. So permanganate is some kind of mouthful. All right. This one is weird. So
It's my turn.
yeah, it is your turn. I'm sorry.
He's looking at it.
Peroxide.
Yes.
Why
So,
not go down my throat?
now keep in mind what's weird about this one, Ethan.
What?
What's weird about it?
There's two Z's.
Alright, so you have oxygen and it's a total 2 charge. So same idea as with the mercury. The same, no, it's not mercury. Same idea as with this one. Alright, so if you have 2 mercuries, I did write mercury. If you have 2 mercuries and the total charge for the whole thing is positive 2, how many did each mercury give up?
Boy.
Alright, so if there's 2 oxygens and the total charge for the whole thing is -2, how many did each oxygen take? It's kind of a weirder one. We don't see oxygen
4.
do this a lot. Nope, 1. We don't see this.
Oxygen.
We don't see oxygen do this a lot. This is why hydrogen peroxide is kind of unique, because we don't see oxygen only take 1. Oxygen traditionally wants 2. So it's kind of a weird exception. Alright, anyone have any questions about that? I believe that's all my guards. So that should be the most of the table. I believe I got them
We
all.
didn't do that bad.
So it's one of those. Once you get them, they're not
I got
hard, but it's something to where you need to learn them. Do you know what the charges? I didn't drill charges, so make sure that you know what the charges for them. Not necessarily for
Wait,
this
what?
quiz. Like the charges, like note, like hydroxide only takes 1 electron. Acetate only takes 1 electron. Not necessarily for this quiz. But keep in mind that you know them because for balancing the ion compounds, you gotta know that.
I don't know. Ethan said we did pretty good, but I was perfect. I mean, I got it all right, so I don't know what he's talking about.
Says book person.
What?
Hmm.
I'm not even on the page.
Alright, look over on page 42. So we've kind of already gone over the naming binary molecules. We've gone over naming the compounds over the past couple of days. I gotta go. We gotta move on. So this chapter is going to get kind of math heavy, kind of quick for it. So we're talking about molecular mass. If you're talking about molecular mass, what am I doing? How am I finding it? All right, Chris.
The mass spectrometer. No, the number, that mass number.
Okay, what's mass number?
Atomic mass unit.
No.
Mass number.
Okay, what's mass number?
unit.
What you're like combining a whole bunch of different things together. All right, what is mass number?
Mass spectrometer.
Okay, what is a mass number first? Because you said that first. You should already know what
Number of
mass.
protons.
Number of protons and.
Electrons. Protons.
Protons.
All of the above.
No. Number of protons and neutrons. That's mass numbers together. Alright, so this is molecular mass. So molecular mass, don't scratch my floor, you're dragging the desk. That's gonna scratch my floor. Fix all your limbs back to where they're
He
supposed
looks like an obtuse alien.
They're like
You're
all
an
over the place. Alright, so if you're talking about molecular mass, am I talking about an atom or am I talking about a molecule?
Or what?
If I'm talking about molecular mass, am I talking about a molecule or am I talking about an atom? It's molecular.
Molecules.
Get up, and it's mass. What am I talking about? What is mass?
Wait.
Okay, loosely. How much matter is on the inside of the object? Alright, so if I'm trying to find the molecular mass of this substance, what should I do? We already talked about this yesterday. How to figure out how much this atom weighs, or how much matter is on the inside? Well, not atom. How much this molecule weighs? What do I do?
I remember.
Technically, it's his turn. Nobody.
Use the number.
Which number?
6.0 or 6.022 times 10 to the 23.
That's Avogadro's number. Not quite there yet. Alright.
You used the periodic table.
You do! So you look up and see how much does oxygen weigh? How much does hydrogen weigh? And you add them together, and that'll tell you how much my total molecule weighs. So, just for practice, and I'm sorry, Jamie and Quentin, that it doesn't show up very well whenever I just grab table over here. Alright, oxygen weighs how much? Chris?
16.
Good job. So 16 times 2, because there's 2 of them. You're going to memorize it. So 16 times 2, because there's 2 oxygens.
36. 32.
32. Alright, do you remember how much hydrogen weighs? But you look, it's fine.
15 point, it's 15, it's 16, 17. No, hold on.
Hydrogen.
I'm going to guess.
Isn't it like 12.01?
No, it's 1.
1.008 specifically.
Oh.
Alright, so how many hydrogens are there?
There's 1.0, so times 2, which is 2.2, 16.
Alright, you add them up together, which is what?
Oh.
This one you can probably-
34.016.
Alright, so.
Six eggs.
6 pigs. Since we weekend to practice this. Alright, so where does this one's sig figs end at, Chris? Tens?
The hundreds place.
The hundreds place? Good job, who's gonna draw me over that one? Alright, where does this one go to?
The hundreds place.
This is thousands, but yes. Alright, so
Yeah.
for addition and subtraction, do I go off the place or go off the number?
Please.
Place, so where does this get rounded to?
34.012.
Yep, so 34.02. If we're talking about the weight, what's the unit? Even. What's the unit?
It's all in that.
Yep, so AMU or just U. Alright, anyone have any questions about how to do that? Fantastic, you can practice by yourself then. Look over on page 44. Application number 1. Calculate the molecular mass of each of the following. Go. This should give you maybe 5 minutes, maybe to figure this out.
All of them?
There's only 3. But yes.
What is CH4?
What is that? What's the name? Look at it. It literally
Carbon
gives you the name.
hydroxide.
It literally gives you the name right there. Methane.
Oh.
Where's methane on the periodic table?
You gotta find C, and then you gotta find H, and then you gotta figure out how many of each you
I
have.
did know that it existed. You have to find C and then you have to find H.
Mhm.
And then you add them.
Yes, but how many H's are in methane? If it's CH4, how many H's are there?
I don't know.
4. Alright, we give about 5 minutes to do this, and then we'll go over the answer together. You can use your calculator. You probably want to for that last one. 'Cause that's kind of a doozy.
And I don't have mine.
You don't have your calculator?
No, I forgot it.
Oh.
Is it in your locker?
Yeah.
There goes your freebie, go get it.
Well, I don't have a freebie.
Oh, well.
I don't need my calculator. I just do it in
Yeah,
my
you
head.
do. Go get it.
I'll get it in my head.
No, you
I
gotta
want
go
to
get it.
hear it.
You have to have your calculator.
Come
You're not
on.
prepared. Go get it. You have not used it yet this class.
Surprisingly.
So just make sure you have a calculator, particularly for this chapter and the next one. It's math heavy.
Oh.
Oh.
Yes, okay.
Which one are you working on?
The last one.
Yeah, that's why I said you want your calculator for that.
That's gonna be a head.
It's okay. Ethan, which one do you want?
The last one.
Okay, we'll give him about a minute and we'll go over the answers. Alright, let's go over that first one. Alright, Chris, with proper sig fig in units, what is your answer?
16.04.
Good job. So for this one, 16.04. What's your units? Good job. So just write U or AMU. Either one works, right? Alright. Ethan, did you get anything different for the first one? Perfect. Alright. What about for the second one, Ethan? What you got for that one?
245.3.
Good job. And then what's your units?
U.
Good job. How did you know to round to the 3 for this one?
Do what?
How did you know to get to this? How did you know to end at the?
Because you go off of place on sig figs.
Yeah. All right. So yeah, since for the first one, Xeon is 131.3, and that means that that one has to round to the 10th spot because that's the least accurate spot for that one. All right. Anyone have any questions about this one? All right. Last one. All right, Chris, what you got?
386.64.
0.64. Alright, super close. Alright, so looking at, no, you have it right. Alright, so 386.64. Alright, what units?
U.
Alright, anyone have any questions about these? This one is, once you understand what you're doing, this is molecular mass. Anyone have any questions about that? Alright, now let's look at Avogadro's number. We talked about this yesterday, we talked through it. So what is Avogadro's number? What is the number for Avogadro's number? Chris.
6.022 times 10 to the 23rd.
Good job. So you have to memorize that. So Avogadro kind of started working with gases, and that's one reason why we named it after him. He did not discover this technically, but he was studying that, if I have the same number of moles, or if I have the same amount of particle, if I have the same volume of gases, that they're related to each other. We're not worried about this with the gas laws later on. But they decided, okay, we're going to name this number after him. The idea behind it is that if you were to measure out in mass in grams in a laboratory, you would have that many actual individual little particles. This allows us to actually work with atoms and be able to basically raise it up to a scale so that we can actually see and actually work with. So make a note, a mass in grams numerically equal to the atomic or the molecular mass in atomic mass units will contain Avogadro's number of atoms or molecules. So if I were to measure out for methane 16.04 grams, how many individual little methane molecules would I have? Chris? I know, I just caught me right, I just took water.
1.
How
4.
many? Well, remember, according to another rule, if I were to take, if this is the molecular weight of it, and if I were to actually physically measure it out in grams,
16.
okay, I would have 16.04 grams, but how many individual little molecules, if I were to stand there and if I could have a microscope and count them, how many individual little molecules would I have? Now remember, this is part of Avogadro's number, or the theories surrounding Avogadro's number.
6. Would be 6.
6.022 times 10 to the 23rd. That's where this number comes into play, because they said, okay, this is Avogadro's number. They figured out that, okay, if I were to figure out what the atomic mass units is of an individual little molecule, and then I actually measure it out in grams, I'm going to have this many individual little bitty molecules sitting there. Now, I can't count them, because this number takes forever, and I can't physically see them. So because of that, this is a lot of why scientists work with Avogadro's number, and they work with them in grams, because you can't work with molecules on the subatomic scale. You can't see one individual molecule. But I can work if I raise them all up, and I can actually work with this many all at once. So that's the idea of Avogadro's number, or working with them in the laboratory. That if I take the atomic mass units and I actually measure it out in grams, I'm going to get, if this is the same number as how much the molecular weight is, I'm going to have Avogadro's number. So if I were to take this one and I were to measure it out in grams, how many individual little bitty atoms of xenon hexafluoride do I have? Individual little molecules, if I were to measure up.
0.2022 times 10 to the 23rd.
Good job.
You're so smart.
Alright, Chris, last
sure
one
you
then.
did.
If I take this one, I measure out in grams, how many individual little molecules do I have?
6.022 times 10 to the 23rd.
Good job. So this allows scientists to actually work with them. So your books point out this basically just takes it to where scientists, instead of working with one individual molecule at a time, you're basically quadrupling it times a very large number. So that way, you can actually work with it and you can actually see them. Alright, anyone have any questions about that? Because sometimes it throws off students a little bit. Alright, what's the term or the unit that we use to give to Avogadro's number? Because scientists, they don't want to say one Avogadro's number or something. So what's the unit that they use instead? We compare it to using a dozen. Anyone remember from yesterday?
Moles.
Mole. So make a note of that.
You
So
were-
1 mole, they abbreviate it mole without the E because they're lazy, just means Avogadro's number of something. So if I have, I'm going to erase my arrows temporarily. So if I have 1 mole, that's not a no. So if I have 1 mole of methane, how many individual little molecules of methane do I have? Ethan?
69.
If I have 1 mole of methane,
6.022 times 10 to the 23rd.
Alright, so if I have 1 mole of xenon hexafluoride, Chris, how many individual little molecules do I have?
6.022 times 10 to the
I'm the one guessing so my losing wins.
Okay, so if I have 1 mole of cholesterol.
6.022
Yes,
times
cholesterol.
10
Yep,
to the
so
23rd.
it's like saying I have a dozen if I it's like saying I have a dozen molecules of methane. That means I have 12. If I have 1 mole of methane, it means I have Avogadro's number. Alright, anyone have any questions about that idea? So mole
So
is
if there
just
was
the
2
unit.
moles, it would be times 10. Times 2.
Yep. Which probably wouldn't work with them on that small of a scale, well that large
It
of
would
a
be
scale.
12.044 times 10 to the 46.
Which would be a lot. Alright, so anyone have any questions though about that?
Nope.
Alright, alright, so now you're just getting into molar mass. Molar mass is the mass per mole of that substance. Its units we give for it is grams per mole. Now, if I have 16.04 grams of methane, how many individual particles do I have? Just making sure. Alright, and if I have 1 mole of methane, how many particles do I have? Okay, so for this one, if I want to measure out 1 mole of methane, how much should I measure out in grams? If I need 1 mole.
6.022 times 10.
No, because I can't sit there and count out 1 atom, 2 atoms, 3 atoms. So if I need 1 mole, what should I measure out? How much should I measure out in the laboratory? Because I can't see Avogadro's number.
Mass number or not mass number, the gram 6.04.
Yep, so for this one, 16.04. So 16.04. So wait, if I measure out that much, I'm going to have 1 mole or Avogadro's number. So it's all of it is related. So that's how come your book's trying to explain it. It feels like you're going in a giant circle. That's the reason why your book explains to you. Alright, if I have 245.3 grams of xenon hexafluoride, how many atoms do I have? Well, I keep saying atoms. How many molecules?
6.022 times 10 to the 23rd.
Alright, if I have 1 mole, how many molecules do I have?
6.022 times 10 to the 23rd.
Alright, but can I sit there and actually count out this? So if I need 1 mole of xenon hexafluoride, how much should I measure out in the laboratory to get 1 mole?
245.
Good job. So it's one of those ones you kind of see, okay, I see what's happening. Alright, last one, Chris, I'm not going to make you go through this again, but if I want 1 mole of cholesterol, how much do I have to measure?
386.64 grams.
Good job.
Ooh, so quick.
Alright. Does anyone have any questions about how to find molecular mass? Is the exact same process as finding, does anyone have a question about how to find
No.
molar mass? The exact same process as finding molecular mass? What's the only difference between this number over here and this number? Well, I changed them earlier. But for finding the molecular mass, what's the only difference between them? Chris?
Nothing.
If this is the molar mass and that's the molecular mass, what's the only difference between them?
The unit.
Units. That is literally the only difference between them. It's the exact same process. Molecular mass is you're saying this is how much 1 molecule weighs. molar mass is, this is how many grams I have to measure up to get 1 mole, but the numbers themselves are the exact same. Does anyone have any questions about that? Alright, let's practice then really quick. Look over on page 44 again, back to application. We're going to skip number 2 for right now, we're going to come back to that. So application number 3 for it. So application number 3, give the molar mass of each of the following substances. So you're just figuring out what is the molar mass. So how do I find the molecular mass? Chris?
By adding the two weights together.
Now for this first one, it's just zinc. So what do I look at to figure out what's the molecular mass of zinc? Yep, just look up periodic table. But remember, if it's asking for this one, molar mass, what do I change the units to?
Gram/mole.
Grams per mole. That's the only difference.
You want to do D?
Do A and B for right now, and then I'll check if you want to try C and D, but I want to check A and B first before we get too far. But it's literally the exact same process as molecular mass, you just change the units. So, number 3, A and B, if you want to go on, you can. I just want to double check the process before we get too far. Page 44. Did you already do number A and B?
I had to do it.
Do what?
I did.
Okay. Do you want to keep going? Ethan, did you finish A and B yet?
Wait, what?
Did you finish A and B yet? Or not yet?
A and B. Oh. Number 3 on application.
Yep.
Oops.
Alright. Well, keep going. I'm trying to do C and D on your own, Chris. Since we gotta wait for Ethan to catch up. What question were you doing?
Are you?
Oh.
Do I have to drink and I just wait?
You can read. Don't you read more?
Where is CK?
It's on period 2.
Somewhere.
Close to the middle, to the right of the middle though. There it is.
Oh. Okay.
Alright, so what do you got for letter A, Chris?
65.38 grams per mole.
Good job, that's perfect. So, I'm on the wrong one. 65.38 grams per mole. Remember, it's the exact same process, just got unit changes. Alright, Ethan, what you got for letter B?
104 143.4 grams per mole.
Good enough, 143.4 grams per mole. So that is correct. Alright, anyone have any questions? Alright, anyone have any questions about how to do this? Alright, do C and D. We'll go ahead and just finish off that. Oh, really quick. Looking at B, this is an ion. So, how do you name this?
Silver chloride.
Chloride, just silver chloride. Making sure since we're practicing what our ion names. Letter C should be hopefully pretty easy.
Nah.
And then that one's straightforward. That last one's gonna be a little bit trickier though.
Nah.
Am I dumb or do I not see sodium on here?
Sodium's in group 1. It'll come with time. You'll start to figure out where they are. You'll just start to learn.
Come on.
Alright, Ethan, what do you got for letter C?
38.20 grams per mole.
Good job.
Where's S? Is SO on here?
No, because that so doesn't exist.
It does. It's an ion, you're right. Do you remember
Yeah, but
for
SO as in-
Na2SO4, do you remember what this ion is? What's the name for it?
Nope.
One of the ones you gotta know from that
Sulfate.
paper? What?
Sulfate.
Sulfate. So,
Yeah, but
yeah, so you're gonna have to find, okay, where's sodium, where's sulfur, where's the oxygen? So really for SO4, you're not gonna have it. You give me another minute or so, Chris, and then I gotta go. It's okay. Just looking for
I'm
sulfate.
just saying I've never
It's
used it.
okay. Alright, are you done now, Chris? Alright, Chris, what you got for letter D? So give us some more space.
142.04 grams per mole.
Good, 142.4 grams per mole.
There's
Alright.
0.4?
Mhm.
Alright.
What?
I thought I didn't hear that.
Alright, do you have any questions about how to solve these?
Easy.
It's one of those ones you but just remember, you gotta have proper units. If you write AMU on the test or quiz, nope, because you're giving me the wrong thing. So you have to make sure you're being careful and thinking what's asking. Alright, last kind of math term for this section, percent composition. Alright, so you've done things like this before, your book just explained it to you weird. So, there are technically 4 people in this class. So two gentlemen with me, and then Quentin and Jamie. So, what percent of the class, what?
Did you actually remember Clinton?
I didn't.
5 people.
Why is there 5?
Because there's you.
I'm not part of the class, I'm teaching.
I'm
Alright,
still
so,
in the class.
well, with the students then, so what percent of the class is male if it's 3 out of 4? What
3
percent?
fourths.
Okay, so what percent?
0.75.
What?
75.
What?
75%. So yeah, you both have the right idea, you just didn't go all the way for it. So 75% of the class is male. What percent of the class is female then?
35%.
Did you say
I
35?
said 25.
25%. Alright,
Excuses,
so
obtuseness.
that's the same idea of for finding percent composition of a substance. We want to know, okay, what's the total mass of the substance, and then how much does each atom make up of that particular substance. So make a note of what percent composition is. To calculate the percent composition of a compound from a formula, we simply find the percent of the total mass that is contributed by each element. So your book walks you through this example of numbers of guys and girls of students. We basically did the exact same thing, you just did it super fast. Now in their example, they had 26 students.
No,
They have 12 girls in the class,
It's
which
crazy. I wish we had 12 girls in the class.
it would be nice to have more students, but that's okay.
More girls.
Well, more of
You see
everybody.
the girl on the edge of the computer?
Okay, we gotta keep going. We gotta keep going. Yeah, I know. They tried to show like a whole bunch of different types for it. But so to find your decimal point for it, you just take the 12 divided by the 46, and then you multiply times 100. That'll give you your percent sign for it. So for number of guys in this particular example, 14 divided by 26 times 100%. That'll give you your 54%. So there are two types of ways you can solve this. Like in this first example, they give you the formula for it. Now I have to find the mass of the substance. So first off, they just give me ethanol. So C2H5OH. Now they put OH over here because this is an alcohol. So that's probably the reason why they stick it. Okay, like chemical alcohol, not like drinking alcohol.
Ooh.
There's a whole different types of alcohol. So that's okay. Let's stick over here. Now to find the percent composition, I have to know how much the substance weighs. If I need to know how much the substance weighs, what do I do to figure it out? Yep, so for this one, I have to figure out, your book does it with molar mass, and that's fine for it. So your book just says mass, but then they switch over and they use molar mass, that's fine for it. But basically, you want to find what the mass is. So if I'm finding out what the mass is, how do I figure this out? You add it up. Alright, I have about 7 minutes. We can do this. Alright,
No.
so what would be the mass of this substance?
24.02 and hydrogen is
1.008 times 5.
Oh, there's technically two of them.
Oh, forget hydrogen.
Why is it like that? Why can't you put the hydrogen with the other?
Because this is an alcohol, is what I was saying. So they're saying, okay, because it's an alcohol, we want it to be noticed as an alcohol, we're going to stick it over here to the edge. So
This is
ethanol,
killing.
the OL is scientists telling each other that this is an alcohol one. Alright, I'm just going to go ahead and write.
46.07.
Yeah, so they rounded. Now again, we technically wouldn't round because we're not done all the way with it. So how much of each car? So I'm gonna write the total mass onto the side so I have
Oh,
to
sorry.
So 46.68 AMU or grams per mole. So this is the mass for it. Now I have to figure out how much of the substance each one contributes. So I have to find the percent. So if this is how much this total thing weighs, I figure out how much does carbon contribute, how much does hydrogen contribute, how much does oxygen contribute. So I have to find out the mass of each individual atom that has contributed. So what's the mass that carbon has contributed? Total mass. Alright, so what's the mass of,
Overflow.
alright, so what's the normal mass of carbon? According to your periodic table.
Like 32.06. It's 32? What's our?
Look at the periodic table.
I'm
Carbon.
trying to guess it. 16 point.
Please.
12.08.
24.02.
12.01, but yes.
But get right.
It's okay. Alright.
I got it right.
It's okay. So that's for now there's two carbons. So what's the total weight for the carbon altogether? And since there's two of them, so 2 times 12.02. That's probably what you were thinking of.
Oh, come on. 24.02.
So 24.02. That's how much.
460.68.
Come on, bro.
What do you
You're
do?
ruining the.
Oh, I did argue down there times by 100%.
Anyway.
Wait, what's your answer?
It was minus 460.68.
Okay, not quite. You're getting too far ahead. So don't move ahead yet. Okay, so this is how much that carbon has contributed by weight. Alright, hydrogen has contributed how much by weight? So there's 6 hydrogens. What's the mass of hydrogen?
1.008.
Alright, so there's 6 of them. So 6 times 1.008.
Couldn't clear it. This 3 stayed there.
I'm gonna write this. I'm gonna scoot this down.
My calculator is retarded. 6.048.
There you go. Alright, and then oxygen. There's only one oxygen. What's the weight of oxygen?
16!
16.00.
16.
You're wrong!
No, that's it. Alright, figure out how much percent-wise each one contributed. So I'm gonna take the weight that each one contributes and divide it by the total weight. Your book rounds, technically you shouldn't round yet, but you can. So you take this number, divide it by this number, times 100, and that'll give you your percent for how much carbon is percent-wise of the tire
How do
ethanol.
you do percent?
Don't know.
You just put times 100 and then add a percent sign to the end.
52.140314%.
52.
So,
1493704.
alright, so for this last step, are we using multiplication or addition and subtraction?
You're multiplying.
Multiplying, so do you go up number, do you go up place?
You're off
Number.
You're
So
right.
this one has how many sig figs?
number. 2. I mean 4.
How many does this one have?
5.
Alright, so what should my answer be in?
4 6.
That's look how I just wrote it like this. Alright, so that's one reason as to how come your book rounds early. Technically you shouldn't round until the very end, but your book knows, oh, we're gonna have 4 sig figs. Alright, so this ethanol is made up of 52.14% carbon. Alright, so same thing for our hydrogen. You take the 6.048 divided by 46.068 times 100. That'll give you how much and that'll give you the percent for hydrogen.
Times 100.
Yep, because that'll move the decimal point to put it into the proper place for percent.
13.13.
13.12.
13.13.
1 2.
13.
2.
What's your
13.
full answer?
13.12841886.
Okay, I can hang on to that much.
13.13 because there's an 8 after the 2.
Yep, so what's it round up to, Ethan?
13.81.
Okay, if your answer is this, and I had to have 4 sig
I'm just
figs.
getting 1 point. 13.13.
Good job.
Woohoo! There you go.
Percent sign. Alright, last one. 16 divided by 46.068 times 100. Can't write little like this.
34.73.
I'm off.
Did you say 44?
34.73.
Get out.
Times 100.
Alright,
34.66.
double check your calculations. So it's 16 divided by 46.068.
16.
According to my calculations, you're not very smart.
Alright, anyone have any questions about
I
how to
know I
start?
did.
Okay.
I had 1 instead of 0.
Oh, I was
Homework
gonna
for
say
this evening.
Yeah, but
34.73.
Good job. Alright, we have any questions about how to solve that?
Homework this evening.
Alright, so your homework, we're going to practice with this first type.
Oh, come on.
So, you're going to do on page 47, you're going to do number 1 in that section review, 3.4. There's 2 parts, A and B. So we practice, just do that one.
Page 47.
Page 47,
Number 1.
number 1, and that's going to be it. But finish reading the chapter because there is math more to go over that tomorrow. So study your table so you don't have one problem. Remember, show me work.
We're done.
Show
We're
me.
done early?
Show me work.
That's insane.
Do
Show
we
me
hope you
work.
can't use not counting points?
What?
Can't.
No.
I know for a fact I won.
I know for a fact I won.
I cheated!
I know
won.
you didn't.
Alright, oh, as a side note, so we can start going over these. What is this one?
I'm good.
Carbon
Acetate.
dioxide.
Acetate?
Oh!
What?
I didn't even know.
Okay, what is this one?
Kung Pao chicken.
Starts with P. Starts with A. Ammonium.
Okay, 2 H's and then this one. So
Dihoxide phosphate.
phosphate.
Oh!